Hi everyone. So we're going to continue interpreting linear equations given some word problems. So let's take a look at this example. It says, starting at noon, Emily observed the amount of snow on her lawn during a blizzard. She wrote an equation to represent S, how many inches of snow were on the lawn. S equals 0.024x plus 7, where x represents the number of minutes past noon. What could the number 0.024 represent in this equation? So here I'm going to just rewrite our equation. So we have S equals 0.024 x plus 7. And the first thing I want you to do is identify the rate of change and the constant, because that'll help us kind of piece together what's going on here. So hopefully you remember from yesterday, the number without the variable is the constant. So that's our starting fixed point. And then the number in front of the x is the rate of change. Okay, so now remember, we're talking about the amount of snow that's accumulating on someone's lawn. Okay, so x represents the number of minutes past noon. What could 0.024 represent? So we want to focus on this 0.024. Now we know that it's the rate of change, so we know that it's whatever's happening over time. So in this question, it says snow is falling in a blizzard. So think about what happens to snow in a blizzard. Over time, that's how much snow is going to accumulate per minute, because x represents the number of minutes past noon. This 7 represents how many minutes were past noon when she started it. That was the starting rate. So it was already 7 minutes past noon, and then it's 0.024 inches of snow per minute. So let's take a look at our choices. So we have the amount of snow on the lawn at 12:01. Nope, we're not talking about specific times here. It's not telling us what x is. So we know it's definitely not this first choice. The amount of snow on the lawn at noon. So that means that 0 time should have passed, and we would have an exact amount of inches on the ground. Remember, this is the rate of change. It's not an amount after a certain amount of time. We don't know how much time has passed, so it's not going to be the second one. How much more snow is added to the lawn every minute? So that seems like that would be the best choice, because that's our rate of change. That's how much snow is building up per minute. So we'll keep that one open, and let's just go to the end, to the last one. The amount of snow on the lawn when the blizzard ended. So same thing here. They're talking about after a certain amount of time. We don't know how much time passed, so we can't say how much snow is on the lawn because we don't know how long it snowed for. So we can't, it's definitely not this last one. So it is this third choice. How much snow is added to the lawn every minute? Okay, let's go to the next one. Okay, here we have this second example. At the beginning of spring, Wyatt planted a small sunflower in his backyard. The sunflower's height in inches h after W weeks is given by the equation h equals 13 plus 2.5 W. What could the number 13 represent in this equation? So let's just rewrite our equation down here so we can piece out some of the parts that make up this equation. Okay, so the number without the variable, that's our constant. So here it's going to be 13. So that's going to be our starting point for whatever we're talking about in this question. And then this 2.5 is our rate of change. So I'm going to just write ROC to kind of save some space here. So we're talking about a plant's height and how much it's growing over time. So that means that this 2.5 represents how much it's changing. Oh, I'm sorry, that shouldn't be an X. That should be a W. I didn't read it right, so make sure you read it right. Okay. So this 2.5 represents how many inches it's growing per week. That's why it's right next to the W. It's 2.5 times however many weeks passed. And now remember, the constant is the starting point. So that means that this sunflower would be 13 inches high, and then plus whatever, how many weeks pass, that additional 2.5 per week. So remember, the constant is the starting point. So that would be the starting height of our sunflower. So let's see what our choices are here. The sunflower's final height, it's not this one because, like we just said, it's the starting height. How much the sunflower grows in inches each week. No, that's not how much it grows. We know that this is how much it grows with 2.5. So that's not it. The sunflower's height when it was planted, that sounds better because that was the starting height. Let's just make sure the last one isn't it, and then we can come back to this one. The sunflower's height after 1 week. So that's giving us a specific time frame. In this question, we aren't given a specific time frame, so we can't say that. So we know that it is going to be the third choice. It is the height when it was planted. It was that starting height, and then it grows 2.5 inches per week. Okay, so make sure you identify your constant and your rate of change, and just remember your constant, that's always going to be your starting point, whether it's snow on the ground or it's the height of a plant. That's always going to be your starting point, and then whatever number is the rate of change next to the variable, that's how much it's going to change over time. So in this case, it was over weeks. And in the last example, it was over minutes, I believe. So just make sure you identify those first to help you out.